Today we will discuss about the electric dipole moment of the nucleus. As we know that electric dipole means the arrangement of two equal and opposite charges separated by some small distance. So that we have shown here. This is the minus q, this is the plus q at a distance d. So now electric dipole moment P equal to q into d as by definition. Since nucleus contains protons and neutrons, so it is to think that whether this nucleus can have the dipole moment. Definitely it has the electric dipole moment. Now this dipole moment is given by D equal to ZE into R. ZE, the charge of the nucleus, and R, the distance between the two centers of one of the protons and second the neutrons. Now generally we take the Z component of this dipole moment. So this Z component is integration Z rho xyz dV. This rho xyz, this is the charge distribution in nucleus relative to the center of mass. So center of mass means center of mass of the nucleons. Z, the distance between the centers of the mass. For atomic nucleus in the ground state, Z equal to 0 because the center of gravity of the proton and neutron coincide. So the distance between them is 0. This shows that here if we keep this Z equal to 0, then definitely the electric dipole moment is 0. Quantum mechanically, the charge distribution is given by rho r equal to summation I equal to 1 to Z E P I R. E, the charge of the proton, PIR, this is the probability of finding the particle in the element volume dV that we have written here. Now this probability is given by this relation integration modulus of psi R1, R2, R3 up to RA, R dV1, dV2 and dVA. A, the atomic mass, where this psi R1, R2 and this RA, this is the wave function of stationary state of the nucleus. Hence this dz that we have here, we can write it integration this summation I equal to 1 to I equal to Z EZI psi R1, R2 up to RA whole square into dV, where dV equal to dV1, dV2 and so on up to dVA. In the ground state of the nucleus, this Z equal to 0, so this dz equal to 0, as I have told here, this Z equal to 0. It shows that the charge distribution in the nucleus is uniform. So generally in the ground state, the nucleus are found. So at that space, this dz is always equal to 0. But if the nucleus is located in non-isotropic space, then this dz is not equal to 0. It means that the dipole moment is not 0. This shows that there is a deviation of the uniform charge distribution, and it may be the prolate type, it may be the oblate type. Generally the nucleus do not have this uniform charge distribution. So this shows that the electric dipole moment in the nucleus exists. Thank you.